Hi, I'm Paul Battaglia, and this is section 7.2, two-variable linear systems. Now that students know more about how to solve systems of equations using substitution, it's time to introduce them to some other methods that they could use. I have Gabe and Brittany here with me, and Brittany, talk to us a little bit about that process of elimination.
All right, so with the method of elimination, there are a couple of things I like to do for my students. I like to make sure that they know that when they're trying to eliminate a variable, that they need to have a positive and a negative.
Right. I think that's
so
really
efficient.
important.
Yeah.
I think when we talk to them about the process itself, and we say, okay, we were going to try and add these columns up, so to speak, and if we have that 5x and that 10x, a lot of times I see students turn that 5 into a 10, and now we really have 20x, and it didn't really reduce to 0, which is what we need. Gabe, talk to us a little bit about some other ways that maybe we need them to interpret the solutions.
So really what we're trying to do here is we're trying to find where two lines intersect.
Right.
And really there's three possible cases.
Okay.
Two lines can intersect at exactly one point,
Correct.
where we have a unique solution.
Right.
They can intersect nowhere, so we can have no solution,
Sure.
and that's the case where we have two parallel lines.
Yep.
Or the two lines can actually lie on top of each other, and in that case we say we have infinitely many solutions.
Right. I think that's important, and when we talk about common errors that students make, I'll often see students take a system, let's say, of two linear equations, and they'll try and multiply, let's say, one equation times a 2 or something like that, and they'll forget to multiply everything in that equation by the 2, or they'll solve and they'll only get one of the variables when they need to get both. Stuff like that.
I actually like to give my students a solution that, a problem that's already worked out, but there's an error in it, and have them find the error so that they get used to kind of checking for errors in their own
That's
work.
a good idea.
Yeah, it's a great idea, absolutely. And finally, if you want to kind of bring it all together, try and give them some real world applications and models, and one of the ways you can do that is try to give them a couple different varied looks. Maybe one you'd give them where they actually have to build the system from the ground up, and then perhaps another application where the equations are already given to them and they're simply finding the solution. I hope these tips have been helpful for you. You find much success in section 7.2.